Hello everyone, my name is Howard. Now my team and I are going to make a presentation about music emotion recognition.
Technology has transformed music players over time, from cassette and CD players to MP3 devices and now AirPods. These devices have become smaller and enhanced in audio quality. This evolution sparked the era of streaming music, with smartphones and platforms like Spotify, KKBox. Users can easily access online music through apps, either for free or via subscribing, enhancing music experience. Music stirs emotion like calmness, happiness, and connection with smoothing melodies, while lively tunes bring energy. It heals, providing comfort in stress and adding emotional expression. Beyond art, music is a vital mode of emotional expression in our lives. Music emotion recognition involves signal processing, AI, auditory perception, psychology, and music theory. Algorithms typically use supervised learning with a learning library. This includes extracting music feature and emotion annotation for model training. The trained model classification emotion in unknown music by generating a feature factor, achieving the desired outcome. In Librasa, there are various methods for feature extraction, and in our report, we employ two. One is MFCC and another STFT. MFCC is a feature used to represent audio signal, simulation the characteristic of the human auditory system. It is primarily utilized in applications such as speech recognition and music information retrieval. STFT, on the other hand, is a time frequency analysis method that decomposes a signal into its components in both time and frequency domain. It provides information about the signal's characteristics at different points in time and various frequency. Automatic recognition of music emotions relies on establishing a psychological model. In this session, we use Sarah's emotion model, dividing musical emotion into 4 categories. Serve as the basis. Energy signifies volume, while accent denote pitch and rhythm. So the model may not distinguish individual emotions. It offers a comprehensive overview of common emotional response, making it suitable for music emotion-related systems.
How to identify music motion by Sayers model. There are 4 indexes to identify music motion. Tempos. Think of tempos as a music speed. It's like the rhythm of your favorite song. Faster tempos often make us feel excited, while slower ones might make us feel calm or sad. Loudness. This is how soft or loud the music is. It's like when someone whispers versus when they shout. Loudness can make music feel powerful or gentle. Pitch. Imagine pitch as the highness or lowness of the notes in a song. High-pitched sound can feel bright and happy, while low-pitched ones might feel deep or serious. Timbre. Timbre is what makes different instruments and voice unique. It's like how you can tell the difference between a guitar or a piano. Timbre adds character and motion to music. For example, look at this figure. The mood happy represent medium intensity, medium timbre, very high pitch, very high rhythm. However, depression represents low intensity, low timbre, low pitch, low rhythm. We use different indicators to label motion, which is why machines can judge music motions.
Hello
Here we
everyone.
are going to introduce how we employ Python to programmatically retrieve music content from YouTube. The code sets an API key variable, which is essential for authenticating requests made to the YouTube Data API. Let's initialize a client for the YouTube API using Google API Client Discovery builds. This client is used to make requests to the YouTube Data API. Let's fetch the top trending music videos. They make a list request to the YouTube API for videos that are most popular in the specified region and belong to the music category. They retrieve details like the video's title and ID. These video features can be changed to target different demographics or content types. And this function forces the response to create a list of music videos. This list represents as a dictionary with the title and video ID. Here we use PyTube, a Python library to download YouTube content. Specifically, it's used here to download only the audio stream of the trending music videos. The script iterates through the top music videos fetched from the API, printing out their titles and ID. For each video, it constructs a YouTube URL using the video ID and then utilizes PyTube YouTube function to fetch the video. The select audio string is then downloaded to a specified output path. After downloading, it prints out a confirmation message with the video title and the location of the saved audio file.
Hello everyone, my name is Howard. Now I'm going to make an explanation of music emotion analysis program. And I derive into 4 different parts. The first part is feature extracting from audio files, and I'll deeply talk about the Brosa library, extract features function, and chroma feature. Preprocessing with standard scatter. The most important part here is the standardization. And the third part I will talk about is SVM for emotion classification. I will deeply talk into training data preparation, SVM model, and model training. Last but not least, I will talk about prediction and visualization, the predict function, and various model visualization. The code on the left-hand side you can see is the Librosa library. The code utilizes the Librosa library for audio processing to extract features from audio files. Features are characteristics of the audio signal that can represent different aspects like pitch, tone, rhythm, etc. And extract feature function. This function is over here on the right hand side as you can see. This function reads an audio file using librosa.load and extracts 2 types of feature. The first feature is chroma feature. It represents 12 different pitch classes and captures the harmonic and melodic characteristics of music. The second feature is combining features. These features are combined and averaged to form a signal feature vector representing each audio file. and I need to do the standardization before feeding into the SVM model. Features are standardized using standard scalar to ensure that each feature contributes equally to the distance computations in the SVM. And now I'm going to talk about SVM for emotion classifications. First, the training data preparation. The code defines 4 different emotion categories. They are exuberance, depression, contentment, and anxious. An exact feature for each category from classical music pieces. Classical music is chosen for its clear expression of major and minor tonality, rhythm, timbre, and melody, which are crucial for distinguished emotions. And here, I want to deeply talk about why I choose classical music for my training data set. In the progress of emotion classification, I focus on using classical music as a primary training set function. Classical music is renowned for its rich emotional express and irritate structures, making it an ideal material to help the model accurately capture and distinguish various emotions. The uniqueness of its music genre lies in its ability to convey emotions and sentiments through elements such as melody, harmony, rhythm, and dynamic variations in a more profound manner. An example of emotion classification, I choose to associate music pieces in anxious emotion training set with sadness or melancholy, such as the flight of the bumblebee. And the Beethoven's third movement of the Moonlight. These pieces convey a sense of urgency and anxiety through choice in rhythm, melody, and timbre. For the contentment emotion state, I select Vivaldi Four Seasons Spring. And summer. These movements use vibrant melodies and energetic expression to evoke a sense of contentment and vitality. In training the depression emotion set, I turned to modern music, such as 错位时空、飞鸟和蝉 and 平凡之路. These compositions typically create a heavy, melancholy atmosphere through deep melodies and emotionally rich lyrics. Lastly, for exuberance category, I choose Beethoven's Ode to Joy as a representative, a symbolic movement filled with strength, joy, and vitality. Such musical selections not only offer diversity and richness, but also ensure that the model can comprehensively and accurately classify different emotion categories. And now, I'm going to talk about the SVM model. The SVC is standard for support vector classification, with probability estimates is used to create a model capable for distinguish between 4 emotion categories based on the exact features. In the model training, the model is trained on the label dataset of extract features with corresponding emotion categories. This is the predict music. As you can see, Canon and he's a pirate, Pascalia strains of Southern victory, and a river flows in you something. Yeah, and as all of this you can see, they have percents of anxious, contentment, exuberance, depression, and as you can see, they are normalized stress and normalized energy. Each represent to how you feel and how stressed are you and how energy are you. And now this is the Theros model. Theros model visualization. The code uses Theros model in a 2D representation of emotion with axis for energy and stress to visualize emotion predictions. Each music file's predict emotion is plotted on this model to show its energy and stress levels. And take these 4 dots as an example. For the anxious part, you can see the victory anxious is 44.24%, is the highest. And for the left-hand side, exuberance, for example, strength of 1,000 men is 33.12%. And he's a pirate. For contentment example is 46.58%. And last one, depression. For example, canon in C is 36.96%. And that's all for my report. Thank you everyone, and thank you for listening.